Have you ever stared at a question on a competitive exam and just felt stuck? Well, this explainer is for you. Today, we're going to break down a concept that is absolutely essential for those tricky aptitude tests, ratios and proportionality. Let's get right into it. So, here's our game plan for today. We're going to kick things off with a real-world puzzle, then we'll build the exact toolkit you need to solve it. We'll decode the basics of ratios, unlock the incredible power of proportion, and then finally put it all to work on some classic test problems. Trust me, by the end of this, you'll be thinking in ratios. All right, let's jump right in with a challenge. Instead of starting with a bunch of dry theory, we're going to look at a problem you could genuinely run into, whether it's on a test or, just trying to follow a recipe at home. So take a look at this. You've got a recipe, you've got a ratio, and you have one quantity that you know for sure. How would you figure out the missing amounts? Just let that puzzle simmer in the back of your mind for a bit. We're about to build the exact toolkit you need to solve it, and then we'll come right back here. Okay, first things first, we need to really understand our most fundamental tool. Before we can even touch proportion or solve any of those complex problems, we have to get comfortable with the simple, elegant idea of the ratio itself. So what is a ratio really? At its heart, it's just a way to compare two things. For every A of something, you have B of something else. It's all about the relationship, and we can write it as a fraction or with that little colon. That's it. That's the core idea. Now, let's look at the official lingo for a second. In the ratio 5:9, the first number is called the antecedent, and the second is the consequent. Don't worry, you don't have to memorize these words for a test, but knowing them just helps you follow along when things get a bit more complex. It's just the names for the parts of the relationship. Now this right here is the single most important rule to remember about ratios. It's the relationship that matters, not the actual numbers themselves. You can scale a ratio up or down, and as long as you do the exact same thing to both sides, the core relationship, the ratio, stays exactly the same. And here we can see that rule in action. The ratio of 4 to 5 is identical to 8 to 10, and it's also identical to 12 to 15. In every single one of these cases, the relationship is constant. For every 4 parts of the first thing, there are 5 parts of the second. This idea of scaling is what makes ratios so incredibly useful. Okay, so we've got ratios down. Now it's time to level up with our second tool, proportion. This is what lets us go from just comparing numbers to actually solving for missing pieces of the puzzle. This is where the magic happens. So a proportion is really just a statement that says two ratios are equal. That's it. If the relationship between A and B is the exact same as the relationship between C and D, then you've got yourself a proportion. Think of it like a bridge that lets us use a ratio we know to figure out one we don't. And this little rule, this is the secret key that unlocks pretty much any proportion problem. The product of the two middle terms, the means, is always equal to the product of the two outer terms, the extremes. Just remember, B times C will always equal A times D. Let's see how it works. We've got the proportion 2 is to 3 as 7 is to some unknown number x. So we apply our rule. The product of the means, that's 3 times 7, equals the product of the extremes, 2 times x. That gives us 2x equals 21. A little bit of simple division, and bam, x equals 10.5. See how that works? It's pretty straightforward once you have the rule. All right, theory time is officially over. You now have the basic toolkit. You understand what a ratio is, and you know how to solve a proportion. So it's time to go back to that mocktail riddle from the beginning and put these new tools to the test. Remember this? A 7 to 8 to 6 ratio of juices. We know for a fact that we have 9 cups of lychee juice, which lines up with the 6th part of our ratio. So the big question is, how do we use that information to find the amounts for the 7 part and the 8 part? What's great is that there's often more than one way to get to the answer. Method 1 is a bit more involved, using fractions to find the total. But method 2, well, that uses the golden rule we just learned. We just ask ourselves, what number do I have to multiply 6 by to get to the 9 cups I actually have? That number is 1.5. So all we have to do is apply that same multiplier to the other parts of the ratio. And just like that, there's our answer. We take our magic multiplier, 1.5, and apply it across the board. The 7 parts of apple juice times 1.5 gives us 10.5 cups, and the 8 parts of orange juice times 1.5 is 12 cups. Problem solved. That is the incredible power of scaling ratios. Feeling good? Feeling confident? Excellent. Let's keep that momentum going. We're going to jump into a rapid-fire round with a few problems you might see on actual aptitude tests. Let's see how our new toolkit holds up under pressure. Okay, here's a classic. This format looks a little weird, right? But it's really just a ratio problem in disguise. Your goal is to figure out the ratio of A to B to C. How would you do it? Here's a hint. Think about a common number that 2, 3, and 4 all divide into evenly. And the answer is the ratio 6 to 4 to 3. The trick is to find a number that 2A, 3B, and 4C can all be equal to. The easiest one is the least common multiple of 2, 3, and 4, which is 12. So if 2A equals 12, A has to be 6. If 3B is 12, B has to be 4. And if 4C is 12, C must be 3. And there's your ratio, 6 to 4 to 3. All right, next up, a problem straight from a TCS test. Here we have two different ratios, but they share a common element, which is Q. The challenge is to link them together into one long continuous ratio. The whole key here is to make the number for Q the same in both ratios. And the combined ratio is 15 to 20 to 24. So how do we get there? Well, we need our common link, Q, to be the same value. Right now, it's 4 and 5. The least common multiple of 4 and 5 is 20. So, to get Q to 20 in the first ratio, we have to multiply the whole thing by 5, which gives us 15 to 20. For the second ratio, we multiply by 4, which gives us 20 to 24. Now they're unified. Before we wrap up, let's look at one final advanced tool for a very specific type of problem. On some of the tougher exams, you'll see these complex mixture questions where something is repeatedly taken out and replaced. For those, there's a special formula you can use as a major shortcut. Here it is. Now, I know it looks a little intimidating, but each of those letters has a very simple job. X is just the amount you start with. Y is how much you swap out each time, and N is just the number of times you do the swap. For those really specific, tough mixture problems, knowing this formula can be a game changer. It's a great one to have in your back pocket. Because at the end of the day, ratios and proportions are so much more than just tricks for an exam. They're a lens, a way of seeing the hidden relationships that structure everything around us, from a recipe in a kitchen, to the scale on a map, to the way markets work. The real question is, now that you have the tools, what patterns are you going to start seeing? Thanks for joining this explainer.